Hey guys, welcome to today's mini lecture. Today we're going to be discussing limiting reactants. And limiting reactants are what controls how much product is going to be produced. So in all chemical reactions, then usually what's going to happen is you'll have your reactants, but as the reaction takes place, one of the reactants will run out. So you run out of one before you run out of the other. But guys, when you run out of one, it doesn't matter which one, the reaction has to stop because there's nothing else feeding it. So just a couple of little vocabulary. The limiting reactants determines the amount of product produced when the reaction stops. And then the excess is the reactant that is in excess. So you're going to have some of it remaining after the reaction stops. So I have two problems, and I went ahead and started setting up the first problem for you. And we're going to go through, and I'm going to talk you all the way through it, and then I'm going to give you a second problem. Now, in this first problem, it just simply says silicon dioxide is usually quite unreactive, but reacts readily with hydrogen fluoride according to the following equation. So first thing I did is I wrote down the equation. Then it says if 2.4 moles of the hydrogen fluoride are exposed to 6.53 moles of the silicon dioxide, which is the limiting reagent? So I go back in and I write this down. Guys, it's very important that you take the time to write this down because it keeps you from getting your numbers mixed up, because we're going to have a bunch of numbers coming at us in a few minutes. So what I do is I went back in, I wrote my balanced equation. So I had silicon dioxide, 2 oxygens. So I have 1 oxygen on this side, so I put a 2 right here. When I put that 2 there, that gives me 4 hydrogens. I put a 4 here, that gives me 4 hydrogens and 4 fluorines. So I am now at a balanced equation. So I'm going to go ahead and do a stoichiometry problem, and I'm going to work it out starting with my silicon dioxide, and I'm going to go to my water. And the way that we start this out is just simply write down what is given, 6.53 moles of the silicon dioxide. Now, since I'm already at moles, the first thing I do is a mole to mole ratio. And that's going to be moles of what I am given versus moles of what I am looking for. So the moles of what I'm looking for goes on top, and the moles of what I'm given goes on the bottom. So now I get this mole to mole ratio based on my balanced equation. So I have a 2 in front of the water. The silicon dioxide, I have a 1. So I'm using that 2 and that 1. Now my moles of silicon dioxide are going to cancel out, leaving me with moles of water. But I'm going to take it one more step. It always is easier if I do the grams of the what I'm looking for. So I'm going to go to the grams of water. So guys, I know that the molar mass of water, because I've done it so many times, oxygen is 16, 2 hydrogens is 2, so that's going to be 18.0 grams per 1 mole. So guys, I'm just going to plug this in on my calculator real quick. So I got 6.53 times 2 times 18.0 equals, and then it's all divided by ones, so it's 235.08 grams. So this is the amount of water that I would get if I could use every bit of that 6.53 moles. So now I'm going to do the same thing, but I'm going to take it to the my other reactant, which is 2.54 moles, and this is going to be of HF. So it's set up the exact same way, and I'm going to do my mole to mole ratio. This time, again, it's water. This time it's HF, but let's look. I've got a 2 for the water, so it goes there. I've got a 4 for the hydrogen fluoride. So that is going to be the numbers that I use for my mole-mole ratio. I'm going to take it to the grams again. So it's going to be 18.0 grams per 1 mole. So I'm going to multiply it out, 2.54 0.54 times 2 times 18 equals, and then I'm going to divide all of that by 4. So this time I get 22.86 grams of the H2O. So if I used all of this, and that was my, I would get this much. But you got to remember, guys, that the limiting reaction runs out first, and that's going to determine the maximum amount that you can get. So this one is going to run out when I get to this point right here. So that means that I could produce a maximum amount of 22.86 grams of water if I was using these 2 moles of concentration. So what is going to be my limiting reagent? The HF is equal to the limiting, and my SiO2 is equal to the excess. Alright, so that is going to be the answer to this question. So I hope that helped you. And the next problem, I'm actually going to work out on my whiteboard, and I'll do that during class. So this was the one to get you started on how to do it.